Namaskaram. Welcome to our live telecast on physical science pedagogy. We discussed various concepts of physical science pedagogy, that is methods of teaching and various plans, different resources, continuous comprehensive evaluation and its tools, how we are going to implement in physical science teaching learning process. Now we are going to learn about the nature of physics. Okay. Already I said the science is science and our daily life situations are both sides of the same coin. You can't divide individually. Both are interrelated. Actually, physics means it's a domain of inquiry. Very important. The science develops on inquiry, organized knowledge, and logical reasoning. These are the three important features for physics. One is logical reasoning, organized study or organized knowledge, and domain of inquiry. These are three important features of physics. When you consider what is logical reasoning, see in the morning walk, some people are doing morning walk on various what you call it as gardens or footpath or something else. When the sun appears, one of the guy will just put namaskar to him because he feels that sun is one of the goddess. Okay, because he gives energy and light. Coming to the other, so he feels that how we get this sun, the light. Okay, he won't believe it's a god. So he will see in a scientific attitude, a scientific manner, how sun get energy and how it is releases the energy. Maybe in both aspects both are correct. Okay, in orthodox way that people will pray the sun because it is an energy, but in a scientific attitude how the energy comes means already you know that inside the this lightest particle in the world is hydrogen, you know that. And I explained that last class as 1H1 plus 1H1 is gives rise to 1H2, 1H2 plus 1H2 is gives rise to 2He3, and 2H3 plus 1H1 it gives rise to 2He4 produced. In the process of producing of helium, so the energy is released in the form of heat and light. Okay, we are getting both. That is called nuclear fission. So due to nuclear fission, so we are getting energy. So here when you see the process in a scientific attitude, then you can understand it. That's the one way. So that's the reason we will say the science is a particular way of knowledge looking in nature. I will write the statement, it's a very important. Particular way knowledge looking at nature. This is the most important. How you are looking, that's a very important. You are looking in a scientific attitude with the help of logical reasoning and in the kind of inquiry, then we can understand the science. Already you know that we can pose so many questions. Just now for example I want to say okay, you are walking on a road in the evening session, just the moon comes, you enjoy the nature. Okay, then when you observe the moon, so if you feel that the moon is coming with you, so what so the children or the student or the person who doesn't have any scientific attitude, he feel that something is going on, the moon is following to me, like he feels. But when he knows that relativity concept, there is no difficulty at all. Correct or not? So here the scientific attitude, how we are looking the concepts or the things or the activities, that will be call it as a science. That's the most important. When you come into the other example, for example, so about electricity. So electricity means so how, so when you switch on, you will get a light, or you will get a fan which is moving. When you switch off, it will stop. How it works? So there will be a magic is going on. So what they learned that a current is nothing but a flow of electricity. Of course, means electrons, free electrons. Electrons are not visible. Then how these one? For example, at Nagarjuna Sagar or Srisailam project, the electricity is producing. From thermal powers also electricity is producing. There the current is producing. But when you switch on that light, here the bulb is glowing. So how it is possible? It comes directly from Srisailam project to at my house. So he has to think that. Means it gives a good reasoning for it. The electricity was produced there, and the distribution centers are there. Through the distribution centers, power centers. So through the transformers, which is nearer to home, from that it will comes. More than 30 kb watts current will come. When you come into our home, it will becomes as just 240 watts. Now see, this is the process. The transformers will control these voltage regulations and all the things. But so it seems initially it seems to be very magic will going on. And just now, see here in Hyderabad through SoFTNET, I am giving a live class to you. The people who are at Kottagudem or Adilabad district, they are also can view these live telecast. Okay. So how these, of course, the total things are telecasted, and what is the process when you think it? It's nothing but science. So science is totally based on inquiry, logical reasoning, and organized knowledge. It's a very, very important. Here, so this what I am saying, the audio session and the video session, of course, visuals are converted into electromagnetic waves. Through electromagnetic waves, it's transmitted from these towers, and of course there at your home, the computer or whatever it may be, the television channels, they receive these signals. They converted these electromagnetic waves into audio and video format. So you are able to see that. Clear? It's nothing but a science. So here, if you understand the knowledge, organized knowledge behind this, the total process, nothing but science. Is it clear? So science is particular way of looking at nature. This is the most important. So you have to think all those things. And next one is science is a rapidly expanding body of knowledge. So it increases. There are so many disciplinaries in science discovered, established every day. And in order to one being we enriched by researches. So now previously we have kinematics, then converted into or enriched into dynamics. And then this kinematics is also developed as dynamics, and it is converted as a thermodynamics. Okay, and kinematics and dynamics we call it as a mechanics, and mechanics is classified, improved as a fluid mechanics. Okay, aerodynamics. See all these, there are different branches of science which are developed through research and other what you call it as explorations. This is the most important. So you have to understand science is a rapidly expanding body of knowledge. This is another one. Science is rapidly expanding body of knowledge. Rapidly expanding body of knowledge. Okay, this is the most important. So through research, through discovery, through different kinds of innovations, so the science is developed, the branches of sciences are developed. So we have the electronics, we have electricity, we have static electricity, and we have modern physics. From that, now we are in the position of nanophysics. So by using the nanotechnology, we developed various branches of sciences. We have electromagnetism, we have magnetism, we have sound, so various branches. So all will develop through various kinds of discoveries and innovations through research oriented process. That's most important. And science is an interdisciplinary area of learning. This is the most important. And one more, it's an interdisciplinary area. Okay, of learning. So why I said it's an interdisciplinary area of learning means, so initially, so you have environmental sciences, that is called EVS. From 3rd to 7th standard, generally we learn the concepts of science concerned to the physical science, concerned to the biological science, concerned to the chemistry, all will comes as environmental sciences. There is no difference. There is no difference between these two because they are interrelated. If you want to explain the chemistry, some physical science concepts are required. If you want to explain the physics, some biological science concepts is required. So like they are interrelated. You can't the living process, the nutrition, okay, and all comes in all these areas. So they are interrelated, interdisciplinary. So when coming to the advanced higher studies from 8th onwards, so 8th onwards, these two are separated as physical science and biological science up to 10th standard. So then when you come into the intermediate level, so when the children is going to complete their adolescence period, when they have some mental maturity, then it is divided into once again as a physical science, of course, as physics and chemistry. Again the biology is divided into botany and zoology. So means that there is a classification. Previously all are interrelated that. Okay, and you are going to learn as a modern physics, and there you are going to learn different kinds of isotopes, isobars, isotones. Okay, all comes as which is concerned to the atom and nucleus. And there instead of we call it as atoms in chemistry, we are using as a nucleides. Of course, terminology is different, but the concept is same. Okay, we will call it as, for example, 17Cl35, 17Cl37. So these are the chlorines. Actually, chlorine does not exist as individually; it exists as an isotope of these two. Means as 17. That's the reason the atomic mass number or atomic mass of a chlorine is 35.5, because so it's available in the form of isotopes in air. In 17Cl35, another one is 17Cl37. Okay, and hydrogen also have different kinds of isotopes, of 3 kinds of isotopes. You know that one is 1H1 hydrogen, 1H2 deuterium, 1H3 tritium. Of course, 1H2 and 1H3 as radioactive properties. They have a radioactive properties. Clear? So we are just we are integrated the concepts of physics and chemistry. So that's the reason we call it as interdisciplinary. Okay, so we are using the concepts of different kinds of solutions and pH values in physics, sometimes chemistry. When you go on advance, so this in post-graduation, for example, so that maths will be classified as again 2 kinds of pure mathematics and applied mathematics. So applied mathematics is nothing but a physical science. See, so it's modified. Previously it was an EVS, then it is divided into physical science and biological science, then it is divided into physics and chemistry, botany and zoology. In advanced and higher studies, again mathematics also becomes as a applied mathematics converted as a physics. So the physics is concerned with all this. This is nothing but it's interdisciplinary areas. So science flourished in ancient culture actually, like Indian, Chinese, Greek, Egyptians and others. The science as we know today is not older than a few hundred years, just a few hundred years. You know that the 16th century is said to be as a black age of science. At the time no one accepted these things. Even you know that we call it as a Copernicus theory and other, of course, Kepler theory. As per that, first our earth is considered as a god previously. So there in Vedas also we learn Aham Brahmasmi. So and still we are praying our earth as a goddess. So Earth will be at the center, these all stars, planets, everything revolving around the Earth. That is called geocentric theory. After that, when the Kepler comes as a gives us Kepler's laws, and he said Earth is just a planet, and these planets are revolving around the Sun, and Earth, and Sun is at one of the foci of the elliptical orbit. And by his theory, he explained how the seasons will come, how it differs, all the things, how day and night will come, everything will be explained is laws, which is true. Clear? So that's the reason. So science is interdisciplinary areas of learning. It's the most important, and which comes as other things. And if of course scientists are comparably recent origin. Earlier science was called as natural philosophy. So that's the reason maximum scientists are called philosophers. Okay, and it's a natural philosophy, they said. And of course they on the Earth, they are sky, of course they will say various properties. Now it is totally as a space physics, astrophysics. Okay, so we assume that Earth is a, of course anyone as a celestial body is in a spherical shape. So these are spinning around itself and revolving around the Sun. Of course when you consider our solar system, I am taking one example, solar system, like we have Milky Ways in the galaxy, and we are going to discuss about the black holes and all these things, so you can understand easily it's an interdisciplinary. Let's take for example thermodynamics. And thermodynamics is a branch of science which deals with the relationships between various forms of energy. Okay, there we are going to learn, so there you are using two words, call it as heat and temperature. And heat is a form of energy, and temperature it is they give the attitude, of course, how we are going to measure the heat energy in particular units, that is called nothing but a temperature. Okay, heat is one, so there we are going to learn of various concepts like specific heat, okay, and boiling points, melting points, and entropy, enthalpy, like various concepts we are going to discuss about that, and what is the process of it. That's a very important. Now coming to the next one, biomolecules. So biomolecules are chemical compounds found in living organism. For example, carbohydrates, proteins, vitamins, nucleic acids, liquids. Study of biomolecule is closely related to the several areas of study such as biochemistry, molecular biology, bioengineering, and like biomolecular structure. So see, you started the syllabi of a concept as biomolecules. Now I will write it. So biomolecules. This biomolecules is concerned with the words, the concepts you are going to learn about as carbohydrates. Okay, and carbohydrates, other one is proteins, vitamins, correct, like other areas of okay, even lipids also we can say it, and nucleic acids also. I will write one more. Okay, so biomolecule is concerned with the carbohydrates, proteins, vitamins, and nucleic acids, and lipids also. Now we are going to learn all these in what is the disciplinaries we are going to learn at biochemistry, any other, bioengineering, next molecular biology, okay, and we can say so many things. Just I am quoted few of them, not fully everything. So this actually I am taking a simple concept, call it as a biomolecules. When you consider biomolecules, it's concerned with the carbohydrates, proteins, vitamins, nucleic acids, lipids, all these things, and these are developed as branches of science. Those are biochemistry, molecular biology, bioengineering. So see, I will give a small example to you. So as even you are going to appear for the examination for this PGT or Gurukul examinations, So I think so maximum 90% of the students are not aware about these things also. What is biochemistry, what is molecular biology, and what is bioengineering, what are the concepts they are going to learn in their learning processes. Means at the time there is simply a common courses is there, and whether you are studying BSc as MPC, maths, physics and chemistry, and in the curriculum of this degree syllabi, or whether you follow the unified physics, generally unified physics is the syllabus for the total. So we can't find all these words. You know by carbohydrates, you know proteins, you know vitamins, you know nucleic acids, you know it, but it doesn't have any awareness about the curriculum of biochemistry and biotechnology, bioengineering and nuclear biology. Am I correct? So here, as the science is developing enormously in various branches, because it's based on the domain of the science is inquiry. So organized knowledge, logical reasoning, scientific attitude, intrinsic heart. So these are the qualities of the science. Then only so introspection, ever people have to take an introspection, also how it is. So sometimes we can't believe it also. Someone will say, we will say as impossible. I will give a small example. At the time of ancient period, as per Indian mythology, the gurus or the muni, which are called it as saints of Hindu system, they close their eyes, they will predict what will happen, what is going on at Himalayas, what is going on at Kashmir, or what is going on other areas, and they will say to that particular people. We heard these stories. So no one believes that. Is it possible by closing the eyes, how you are going to predict what happens in the particular areas? But the concept is maybe useful for the scientists. So some people will see only in a narrow way. When some people will see in a scientific view, then that will be converted as what you are seeing the television channels. Am I correct or not? Here from Hyderabad we are telecasting this live program. In Adilabad you are going to see that. Means nothing but it's like imagination of that. That is imagination, it is realistic. So we make the imagination to realistic. In Ramayana you learn that about the Pushpak Viman. We didn't see the Pushpak Viman. So all these people who are from Sri Lanka, so they came to the Ayodhya along with Rama and Sita. So that's a story in the Ramayana. But they are flying through the flying mission, of course flying boat, they came from the Lanka to that Ayodhya. The development of that is nothing but what present use aeroplanes. So there is no scientific attitude and no scientific knowledge there. Here we have the scientific knowledge, how these aircrafts will travel at. Even in Mahabharata you heard about this the what you call it as the Kauravas. So one what you call it as one thing is divided into 100 parts, and those are 100 Kauravas, they said. Okay, so at the time imagination is very difficult, but recently now test tube babies are here coming. So it's a base and root of those things also maybe. So nothing is impossible. This is a very important. When you add scientific things, then you can do miracles also. That's the most important. Clear. Coming to the next one is surface chemistry. So surface chemistry, you know that it deals with phenomena that occurs at the interfaces of surfaces. That's very important, and we call see. I'm going to introduce a very good new names of new branches of science which is totally unaware about you, but I'm giving that information to you. Maybe this information is highly useful for your examination. Not only in your examination, you can, because as a teacher you have to enrich and enhance your knowledge. We will give a good information to the children, then only they can appreciate the learning process and they will enjoy the learning of physical science. So in another one, you know that that's called surface chemistry. Okay, so what is surface? Have you heard about this word, surface chemistry? So surface chemistry deals with the surface interfaces of surfaces. Okay, there is adsorbents, and there will be cohesions, heterogeneous catalysis, and crystallization, colloid formation. This is the most important. Okay, so I don't want to go in depth, but this surface chemistry will help to all of you to know how the colloid system will go. So in the Newton's third law, of course, and Newton's application, we are going to apply all these things. Now coming to the next one, science is a truly international enterprise. So it's a truly international enterprise. It's international enterprise. Can you say what is international enterprise? Why science is called it as international enterprise? Can you assume that why I said these words? There is another aspect of modern science. Now we are in the modern science, needs a consideration as men and women of all countries participates in the progress of science and its application. Correct? Okay. Most big projects in science are undertaken by the teams of scientists drawn from the many countries. This is because of human and financial resources. Correct? And the mapping of human genome involved in the scientists from many countries. So here we are using so many things like conceptual mapping, mind mapping, brainstorming, conceptual flow. All these things will give the information to how the concepts will flow in it. So because science becomes now good enterprises, and the scientists will becomes as an entrepreneurs. So here it becomes as a science. Its sense means science does not belong to any single country or any group of countries. It would be morally, ethically wrong to deny the fruits of scientific development to any country in the world. So no country has a right to say this branch of science, a part of science is concerned to our country. So there is no possibility. If you say it's ethically and morally, this statement is wrong. So there is no patent to any people, any country. This branch of sciences was concerned to us. Okay, they may be try for the patent for their works, but you can't say the branch of science. This branch of, for example, thermodynamics or the molecular biology, or just now what I said, surface chemistry, or nuclear chemistry, and nuclear biology, or nuclear physics, or optics. Whatever it may be, the branch of science, so we can't claim that this purely belongs to us. So there is no, when you say anyone, it's ethical. That's the reason if we said the science is an international enterprise. So very important. So maybe this same kind of questions may come in the examination. How science is a truly international enterprise means you have to say that. So every country, man and woman of all the people, all from the world, can participate as individually, as groups. They develop the things by the through discovery or innovation, and they develop one branch of science. But there is no possibility to claim that that country is concerned to the total branch of that science. That's the reason we call it as it's a truly international enterprise. And science is always tentative. This is the most important. Science is always tentative. Okay, so can you understand what is science is always tentative? Why I said so here the earliest theories of universe held the earth to be center. Just now I said this is the most important. Previously we have geocentric theory, correct? Means earth is at center, and all the planets including sun around the earth revolving around the sun in a elliptical orbit. This is called geocentric theory. Okay, so up to 17th century, before the Kepler and Copernicus, they feel that it's true. After introducing Kepler's laws, and then it is converted into heliocentric theory. Means your sun is at center, and around the sun all the planets are revolving around the sun in elliptical orbits. Okay, so it's not tentative. Here the concept is changed, totally changed. Okay, and even other things also we can say. That's you learned it, and one more. And of course Newton's theory of mechanics. When you come to the Newton's theory of mechanics, held away that in 100 years also. Previously there is even for Einstein, so something E equal to mc square. This is nothing but resemblance of physical science. So everyone accepted, but there is a research is going on. So E equal to mc square, there is some exceptional cases. So we have to introduce that, and some research is going on. the vastness of biodiversity has always attracted not just lay persons but also scientists. So this is a very, very important. So what we learn in the previous era, so maybe there is some changes, there may be some changes, or totally it is there may be a controversy for that. Even in what you call it as, let's take the process of knowing about the atomic structure, because it's a part of your textbook. That's the reason I'm going to take the same example. So when you come into the atomic structure, so first Rutherford said, and of course Rutherford, you know that before Rutherford, J.J. Thomson theory is there. Am I correct? So J.J. Thomson theory, as per J.J. Thomson theory, we call it as a watermelon theory. So in atom it's nothing but like a watermelon. So the total positive charge is like what you call it as a flush in the which is in the red color, and the electrons are which like seeds in the watermelon. So means is it correct theory? No, actually it's not correct, because so a small quantity of electrons are in the huge quantity of protons, means the positive charge is more and the negative charge is less. So definitely there is an attraction between these two. Finally no atom will be adjusted. But why you are saying about still you are saying about J.J. Thomson theory? You know that this is the first atomic structure, so we are giving importance for that. Previously we doesn't know that, because as per Dalton, the smallest particle in the substance is an atom. In up to 16th century everyone accepted. Okay, after so many experiments, you know that maybe Johnson Stoney, Rutherford, of course, invented this cathode rays, of course, sorry, cathode rays, it's correct, it's electrons, Johnson Stoney named it. Goldstein, okay, tried to give the name for the protons, and Chadwick given introduction about, or introduced about neutrons. Then so electrons, protons, neutrons are the small particles which are inside the atom. Previously it's undividable, and atom is the smallest particle. Then it is modified. Then we comes to the from electrons, protons, and then we started the atomic structure. J.J. Thomson said, of course, it's in the like a watermelon, and we ruled out that it's not correct. Then Rutherford came. He gave some what you call planetary system model. Okay, around in the atom there is a at the center we have a totally vacuum, and the total positive charge is concentrated there. Around the nucleus, electrons revolving around the nucleus in circular orbits like planets, he said. After that, when Schrodinger comes, he said no. So electrons are not revolving in the circular orbit, they are revolving around the nucleus in elliptical orbit. Clear? And of course, so there is no explanation how the energy is released or how the energy is absorbed when the electron jumps from one orbit to another orbit. Correct? So then the Niels Bohr is started by using Max Planck quantum theory. He said, so the electrons are revolving around the nucleus in stationary orbits, there is no losing of energy, but there is some what you call drawbacks there. It is modified, then Schrodinger introduced that. Again we electron model theory is there. This, see, I think so this example gives, first atom is a undividable substance, smallest particle in the substance. From that area to the electrons revolving around the nucleus in elliptical orbits. So how science was improved, and there is so many researches are going on, and they are saying the alpha rays, beta rays, artificial radioactivity and natural radioactivity, and we are using that radio waves for various purposes, and introducing of laser technology. So how, that's the reason. So we can say simply science is totally tentative. So that's there is no rigidity that it will always change, it will always be modified, and it's based on experiments, research, innovations, discoveries, adding logical reasoning and thinking. That's very, very important. And all theories in science have the status we know then at this instant. Mostly we know the process. That's very, very important, how science is going to be developed. Okay, so we now from so there is a development from bullock carts to rockets. Correct? From kerosene to now you are using petrol. So like so we can say so much development. So science is rapidly developed. So that's the reason. So we can say the science is always at tentative. Okay, now coming to the already I said there are so many theorems, of course, thesis about the tentative nature of science. So you know that Karl Popper is one of the scientists, and scientists prefers a theory which explains a large number of observations by using fewer assumptions. So this is a very important. Sometimes we are using assumptions, then that assumptions will be experimented. After that experimentation, we can say the extension of the science. That's the most important. Now coming to the next one, is science promote skepticism. Scientists always are skeptic people. This is the most important. They won't accept the things what is actually happens. So they will see always in a. I will give a small example for science, and of course we are teaching with the physical science teaching. So you know that I gave the same example then, but it's a consent to the topic. You know that Albert Einstein, of course, a very familiar scientist, and at the time there is no communication system. There is no communication system. He gives explanation about his invention in all the universities. One of the university, Cambridge University, his car driver said, sir, you are repeating the same thesis every university. I by heart the total thesis, so now I am able to explain those things. I can give a seminar at Cambridge University. No, so science is not, of course it seems to be tentative, but it seems to be easier, but when you go in depth, so there should be a good logical reasoning is required, like he said. No sir, I know each and every word consent to the E equal to mc square. Okay, he accepted. There is change of dresses of Einstein and his car driver. Okay, actually at the time no one knows who is Einstein. They knows about his theories, but they doesn't know the picture of Einstein. So no one is recognized Einstein. So that's the reason the dramas are changed. Okay, then at the time he gave the extraordinary explanation about the E equal to mc square. The process is over. After the seminar, the generally announcer will ask any queries or doubts about this thesis. Means so actually he knows up to that only, because he doesn't know the thesis. At least what is the theory and how it is related with all the things, and what are the limitations, or can you apply for anywhere. Like he doesn't know anything, just he knows only the thesis part only. So immediately what he said, so I am busy, so my car driver will explain these things, and simply escape it. So generally in teaching of physical science, we will say, for example, of presence of mind. That's very important. So I don't want to say you should escape from the doubts of the children. It's not the meaning, but actual thing is so science has good experimentation. It's based on good experimentation, observations, investigations, logical reasoning, and scientific attitude. Am I correct? So that's the most important, and scientific process purpose is that scientists will acquire, analysis, and report the data honestly. That's the most important. They have to acquire the report or knowledge in a honesty way. Honestly, that's a very important. At the same time, they have to analyze and they have to acquire that information in a good manner. This is the most important. And very important thing is science demands preservation from its practitioners. So who practice the science? Because science, caste science is that not generally highlighted. This is very important. They have to practice the things of all these things. That's the most important. Now I am coming to the next one. This is the most important. I will give a small example. The discovery of X-rays. So who invented X-rays? Can you say that? Röntgen, correct. So Röntgen invented the X-rays, also underlies the importance of the attaining the science which training science should ensure. Without this attaining, Röntgen would not have grasped the significance of this chance observation. So what will happen, how they are discovered, that's the most important. Already I said so many examples about Wright brothers, so who invented this aeroplane. So they do so many experiments, but finally they are find out this aeroplane. That's a different thing, but So when they observe the any bird or something, the birds are flying. So why we are unable to fly on it? So simply they prepare two wings and hold it to body, and they jumped from a wall, they fallen. After that they tried so many times, and they will be they are failed in the attempts. So they collected all the papers, and of course they fired it. So at the particular instant what they observed, so the hot air, where they observed hot air, in that air the black pieces he observed. How these black pieces are moving? Means here hot air will be as per the density, it's a lighter. Then they prepare a parachute, and they make hot air, and they fill with the hot air. Then they started on the flying. After that, you know that everyone knows the remaining process. Finally they invented this aeroplane. So scientific attitude is the most important, and the discovery process means you always think in a right approach. That's one more important. Okay. So here the very important thing is science is an approach for investigation and as a process of constructing knowledge. Very important. Approach to investigation. Approaches to investigation and construction of knowledge. Clear? So these are the very important points on the nature of science. So here actually the science is an approach. The science is an approach to investigation, very important, and a process of constructing knowledge. So through investigation they have to identify their observations in a scientific manner. Finally they have to construct the knowledge. That's the most important. And in this process, and we have to discuss about the various one is called observation. That's very important. Observation is very important. Okay. So here what is the observation? Just now I said so many examples, and you learn also so many examples about the observation. So small insects are walking on the surface of water. Is it possible for us? No, it's quite impossible for us. Okay. So what is the reason here? That is called surface tension. Okay. So when you put a small cloth inside one bottle, and when you lighten up, when you pour with oil or kerosene, then what will happen? That its a light will be glow, correct? So how this liquid moves upwards? What is the reason? It's a cloth, so it's a mix up with some threads, and of course between the threading, so there is some gaps. In that gap air will be filled, and air has the pressure. So pressure means it pulls upwards. When it pulls upward, the liquid will climb through that pressure, and finally it burns, which provides the light. Am I correct? So here observation is very important. And when you say any liquid drop is in spherical shape, so any liquid drop is in spherical shape, what is the meaning for it? So here when you consider when you consider as a cuboid or cube or a cylinder or hemisphere or sphere or cone, various kinds of three-dimensional shapes. So if you take among those with the same dimensions, so the smallest volume occupied by only the sphere. For that reason, every liquid in the form of course liquid drops in the form of a sphere, spherical. Water drop is in the form of sphere, correct? And one more, this when you take a water drop when the rain comes, which lies on the of course leaves, it becomes as a prism. Becomes as a prism. Act as a prism. When acted as a prism, when the light ray incident and act, that prism, which is a water drop, will scatter the light in the form of VIBGR. Of course, we call it as a rainbow. Clear? So this is all this comes from the observations. We can understand the concepts through this observation. This is very important. In any science experiment, in any science experiment we will write the observations. That's the most important. The rainbow is always seen in a direction opposite to the sun. This is the most observable thing. So I am repeating this. The rainbow is always seen in direction opposite to that of sun. So for example, sun is in east direction, of course sun is in east, then the rainbow will form an opposite direction, which is completely opposite to the direction of a sun. Very important. It's a fact. It's a fact. Can you say the reason? Because every time or any time an observer observes a rainbow, it is found to be in the direction opposite to the sun. Can you say the reason? There is a reason. Find out. That's very important. A ball rolling on a surface comes to stop after some time. It's a fact, because it has been repeatedly verified. Just you throw a ball on a surface, after some time it was stopped. Okay, it's an observation. For example, you tied a ball or something, any object, and moving in a circular object of circular path. When you left it, what will happen? So when it is moving in a circular path, when you left here, so if draw a tangent line to that, through the tangent line, either in direction, of course, if you have upward direction, if you draw a tangent line, so in this direction, so the ball or object will go upwards. If you downs, it comes as a downward. So means here this is the direction of the ball will be projected or moves upward direction. Okay, this is the most important. When you project a ball in a vertically, when it attains some height, its velocity becomes 0 and it ball drops from it. Okay, so any body which is projected upwards comes towards the earth. What is the reason behind it? General thing is all things will come set, but when you apply the scientific observation, it is called acceleration due to gravity. That's very important. For example, when you take a sphere, of course our earth has a sphere, assume the earth has a sphere, so make a hole through the diameter from north pole to south pole. You make a hole completely with some radius and as one path. Just drop a ball through that from north pole. Is it reaches to south pole? Is it possible? It's not possible. That's the reason is it oscillates at the center. It oscillates the center. So when you're traveling in a lift, just when you're moving in a lift, suddenly the wires was broken. What will happen? You feel weightless. You feel weightless. The reason is, so there W equal to weight of your body is m of g minus a, and when it is equal to this acceleration due to gravity we equal to a, or a becomes as z, that is m of g minus g, which becomes 0, means you feel weightless. Okay, that's very important. For example, a railway porter is climbing, of course, lifting some weight from railway station platform to outside of the railway station. After some time, then you can say, I am no need to pay money for you. You can say it's a funny thing. You can say like, as per science, the work done by him is 0. What is the reason? So you know that W equal to, of course, work Fs cos theta. So means here, so for example, he is a porter, he climbs the weight on it, is walking in this direction. So here this is the displacement direction and this one is a force direction. Means what is the angle between these two? It is 90 degrees. You know that cos 90 is 0, then work done by him is 0. Correct? So as for science, so if the work done by the porter is 0, so I won't pay any single pay, means that he is a railway porter, accepted? Not. So that's most important. So you have to know that here, but of course for his muscles are working and muscle power is working to carry that for a while, for a time. So hence we are paying amount for him. That's very important. And so for example, if you give some observations is given, a piece of solid, the solid has shining appearance. The solid can be beaten into sheets, like we can give so many things here. And the most important is the concepts. Many concepts can be combined in a way to convey meaning which can be tested, verified universally. That's a very, very important. Then they become as a principles. Okay. So we will give some statements. We will give some statements, and the statements are generally says accepted everywhere. Then it becomes as a principles. Okay. For example, I say metals expand on heating. Am I correct? So when you take any kind of metal, when you heat it, that they will expand it. So it is nothing but we will consider as a principle. Consider as a principle. Am I correct? So there is some exception cases. You have to maintain it. See, instead of, for example, if you say any liquid, when you heat it, so it expands. But at 4 degrees Celsius, the water cannot be expanded. Instead of expanding, of course, instead of sinking, when you, so here that is called enormous expansion. So you are just decreasing the temperature, you are cooling the water, then generally what will happen? So there is no expansion of it. It gets sinking. Correct? It's converted in terms of ice. But at 4 degrees Celsius, instead of sinking, so it expands. That's enormous expansion of water. So like there is some then some exceptional cases, but when you say all this, just now I said the electrons revolving around the nucleus in elliptical orbit, you said, Schrodinger said it becomes as a principle. And if you say light ray, the light ray has two properties. One is called linear property. As for Newton theory, it's light will travel in a linear path. Okay. So and another one, Huygens, according to Huygens theory, this of course light ray is moves or travels in a wave. So that's called wave theory. Even you can extend for electrons also. Electron has a particle property, but as per the de Broglie, electrons has a wave form, because it's an electromagnetic wave. Like we can say the different concepts which are generally accepted by everyone as a principles. These are the different concepts which is concerned to the nature of physics. Maybe you understand all the things. So anyway, thank you for listening. Tomorrow we will meet with another concepts of pedagogy of physical science. Namaste.